Electrical storms can wreak havoc on sensitive electronic equipment, especially in remote tower sites with backup generator systems. The scenario described, where multiple sites experienced electronic failures after a storm, suggests a surge event that wasn't adequately contained by the existing protection measures. Understanding the potential pathways for surges and implementing robust protection strategies are crucial for preventing future damage. Let's delve into some likely contributing factors and mitigation techniques. Firstly, direct lightning strikes to a tower can induce massive voltage surges in the electrical system. Even near misses can generate significant electromagnetic pulses that couple into wiring. Secondly, ground loops and inadequate grounding systems are significant contributors. In a properly grounded system, surge currents are safely diverted to the earth. However, if the grounding is insufficient or if ground loops exist, these currents can find alternative paths through sensitive equipment, causing damage. Thirdly, the transfer switch, while designed to provide seamless transition between utility and generator power, can also be a point of vulnerability if not properly surge protected. Surges can enter the system through the utility feed and propagate towards the generator and connected equipment, or vice versa, during switching. Fourthly, the diesel generator itself is a potential source of surges, especially during starting and stopping. These internally generated surges can further exacerbate the problem if not properly suppressed. Fifthly, the remote location of these towers presents unique challenges. The LAN cable runs between the utility source, the transfer switch, the generator, and the equipment act as antennas, effectively increasing the susceptibility to induce surges. To address this issue, a multi-layered approach to surge protection is essential. This involves implementing surge protective devices, or SPDs, at various points in the electrical system. Firstly, install a high-capacity SPD at the main service entrance to protect the entire site from incoming surges on the utility feed. This SPD should have a high surge current rating to handle large lightning strikes. Secondly, install SPD at the transfer switch to protect it from surges originating from either the utility or the generator. These SPD should be specifically designed for transfer switch applications and coordinated with the main service entrance SPD. Thirdly, install SPD on the generator output to protect it from internally generated surges and to prevent surges from propagating to other equipment. These SPD should be selected based on the generator's voltage and current ratings. Fourthly, install SPD at each piece of critical equipment, such as radio transmitters, receivers, and control systems. This provides localized protection and prevents surges from reaching sensitive components. In addition to SPD, a properly designed grounding system is paramount. Firstly, ensure that all grounding electrodes are properly sized and installed according to the National Electrical Code (NEC). Table 250.66 provides guidance on the size of grounding electrode conductors based on the size of the service entrance conductors. Secondly, bond all metallic components such as the tower structure, equipment racks, and conduit to the grounding system. This creates a low impedance path for surge currents to flow to ground. Thirdly, minimize ground loops by using a single-point grounding system. This means that all grounding conductors should be connected to a single grounding electrode, rather than creating multiple ground paths. Fourthly, regularly inspect and test the grounding system to ensure its integrity. Soil conditions can change over time, affecting the effectiveness of the grounding system. Consider using ground enhancement materials to improve the conductivity of the soil. In addition to surge protection and grounding, consider the following best practices. Firstly, use shielded cables for all critical circuits to minimize the effects of electromagnetic interference. Shielded cables provide a barrier that prevents induced voltages from reaching the conductors. Secondly, implement proper bonding techniques to ensure that all metallic components are electrically connected. This minimizes voltage differences between components and reduces the risk of arcing. Thirdly, install lightning rods on the tower to intercept direct lightning strikes and divert the current to ground. Lightning rods should be properly sized and installed according to industry standards. Fourthly, implement a regular maintenance program to inspect and test all surge protection devices and grounding systems. This helps to identify and address any potential problems before they lead to equipment failure. Fifthly, consider using a surge suppression power strip for sensitive electronic devices. These power strips provide an additional layer of protection against surges and can help to prevent damage to valuable equipment. Furthermore, the transfer switch configuration plays a vital role. Firstly, consider using a closed transition transfer switch. These switches briefly parallel the utility and generator sources during transfer, minimizing voltage transients. However, they require careful synchronization and coordination. Secondly, ensure that the transfer switch is properly rated for the load it is switching. An undersized switch can overheat and fail, potentially causing a surge. Thirdly, implement a lockout mechanism to prevent the generator from starting during a lightning storm. This can help to prevent surges from being injected into the system. Lastly, consider using an uninterruptible power supply or a UPS for critical equipment. A UPS provides a continuous source of power during power outages, preventing voltage sags and surges from affecting the equipment. The UPS can also provide surge protection. Analyzing the specific equipment that failed and the location of these failures can provide valuable clues about the source of the surge. For example, if all the failures occurred on equipment connected to a specific power panel, it suggests that the surge may have originated from that panel. If the failures were concentrated on equipment located near the tower, it suggests that a direct lightning strike may have been involved. In summary, protecting remote tower sites from electrical storm damage requires a comprehensive approach that includes surge protection devices, a robust grounding system, and best practices for installation and maintenance. By implementing these measures, it's possible to significantly reduce the risk of equipment failure and ensure the continued operation of critical communication systems. The selection of surge protection devices, or SPD, should be done according to UL 1449. It is critical that the surge protection devices are properly sized for the anticipated surge current, voltage, and that they are installed per manufacturer's instructions and local electrical codes. They should be selected by a licensed professional. The grounding electrode system should meet or exceed NEC Article 250 requirements, and specifically the requirements in 250.50, 250.52, 250.53 and 250.66. All grounding connections should be properly made and inspected according to industry best practices. Remember to use appropriately sized conductors according to NEC Table 310.16. All conductors should be properly insulated and protected from physical damage. The remote location may make regular inspections more difficult, so consider remote monitoring of the surge protection system and grounding system to detect potential problems early on. In addition to protecting the electrical system, consider protecting the communication cables that run to the tower. Surge protection devices are available for coaxial cables, Ethernet cables, and other communication lines. These devices can help to prevent surges from entering the equipment through the communication cables. Finally, employee training is essential. Employees should be trained on the proper procedures for responding to electrical storms, including shutting down equipment and disconnecting power. They should also be trained on how to inspect and maintain the surge protection and grounding systems. Regular training can help to ensure that employees are prepared to protect themselves and the equipment during an electrical storm. In conclusion, a multifaceted approach is needed to mitigate the risks from lightning strikes and power surges, including proper grounding, the use of surge protection devices at multiple points in the system, and rigorous maintenance and inspection programs. This, coupled with properly trained personnel, can protect equipment and keep critical systems running.